Hello everyone, welcome to my YouTube channel. In this video, we will solve some of the MCQ from the chapter on real number. The first question is, if n is a natural number such that n is greater than 1, then 2n plus 1 holding square is option A, an odd number, option B, even number, option C, negative integer, option D, imaginary number. So here the correct option is option A, an odd number. So let us take some examples. So when n is greater than 1, it implies that n is equal to then 3, then 4, then 5, and so on. So let us see for n equal to. When n is equal to, then 2n plus 1 holding square is equal to. So when we put n by 2, so 2 into 2 will get 4, then plus 1, then holding square. So 4 plus 1 will get 5. So here we can write 5 square, which is equal 25. When n is equal 3, so 2 n plus 1 holding square. So 2 into 3 will get 6, then here plus 1 holding square. So this one we can write 7 square, which is equal 49. So when n is equal 4, then 2 n plus 1 holding square. So 2 into 4 will get 8, then plus 1 holding square. So 8 plus 1 will get 9, 9 square will get 81. So when n is equal 5, so 2n plus 1 holding square. This one is 2 into 5 become 10. So plus 1 holding square, which is equal to 11 square, which is equal 1 to 1. So all these, they are odd number. So therefore, if n is a natural number, n greater than 1, then 2n plus 1 holding square is option A, that is an odd number. So the second question is, if n is a natural number, n greater than 1, then 2n holding square is option A, an even number, odd number, 1, and option D, 2. So here the correct option is option A, an even number. So when we say n is greater than 1, which means n is equal to, then 3, then 4, 5, and so on. So let us take some examples of this one. So now, when n is equal to, then 2n holding square, this one is equal to into 2, then we'll get 4. So here become 4 square. So 4 holding square, this one will get 16. Next, when n is equal 3, this one will write 2n holding square, so which is equal to 2 into 3 holding square. So 2 into 3 will get 6. So here 6 square, which is equal 36. So when n is equal 4, so 2n holding square, this one can be written as 2 into 4 holding square. 2 into 4 is 8. So 8 square, this one is 64. When n is equal 5, then 2 into n holding square, which is equal to into 5 holding square. 2 into 5 is 10, so 10 square is 100. So for this one also we can write 2 into 2 holding square. 2 into 2 will get 4, so here 4 square will get 16. So this one will keep on going like this, and all these numbers are even number. So therefore the correct option is A, which is it is option A, an even number. So the next question is, if q square is an even integer, then q is option A, odd integer, option B, even integer, option C, 5, option D, none of these. So here the correct option is option B, which is an even integer. So let us see one example of this. So if q square is an even integer, then there is a possibility that q is even integer. For example, suppose we have q square is equal 4, which is even. So from here we can write q is equal plus minus square root of 4. So here square root of 4 we can write as q is equal plus minus 2. So square root of 4 is 2. So here it implies that q is equal minus 2 or q is equal plus 2. So both of these numbers are even. So therefore the correct option is B, which is an even integer. So now we'll go to the next question. The question says the decimal expansion of a rational number is option A, non-terminating, option B, non-terminating and non-repeating, option C, terminating or non-terminating repeated, option D, none of these. So here the correct option is C, which is terminating or non-terminating. So let us take some examples on this problem. So one example, let us take a number 1 by 2. 1 divided by 2. So here we can write 2 into 0 is 0. So 1, put here point and put here 0. 2 into 5, which is 10. So here the remainder is 0. So if the remainder is 0, then we call terminating. So this one is equal 0.5. Another example, let us take 2 by 3. So here if we have 2, then we'll divide by 3. So 3 into 0 will get 0. Then 2 minus 0 is 2. Put point. Here we can put as 0. So 3 into 6 is 18. Then 20 minus 18 become 2. So here again we'll put 0. 3 into 6 is 18 and so on. So this one will keep on repeating like this, and in this case r it is not equal 0. But this decimal is keep on repeating. So here 2 by 3 can be written as 0.6666 and so on, with no terminating decimals, but the decimals keep on repeating. So here the correct option is C, terminating or non-terminating repeated. If you like my video, please click the subscribe button and the bell icon so that you will not miss any updates. So the next question is question number 5. The question says every composite number can be expressed as a product of option A, co-primes, option B, primes, option C, even number, option D, none of these. So here the correct option is option B. which is primes. So let us take one example of this. Let us take one composite number, let's say 12. So 12, here we can write as 2 into 6 is 12, then 2 into 3 is 6. So this one can be written as 2 into 2 into 3, or 2 square into 3. As we can see from here, 2 and 3, they are prime numbers. So therefore, the correct option is B, primes. If you want to know more the concept on number, you can click the link in the description below.